Hello, welcome to the screencast recording for Devops milestone 2. The team consists of Sharat, Swagat, and myself, Rahul. For this project, for this milestone, we have chosen the project Kafka Custom Serializer. Um, this is mainly a Maven project, and this is an open source Maven project. So let's go to the different steps, the test suites. So in order to implement the first phase, we've used Cobertura. As you can see here, the Cobertura plugin has been included in the reporting section of the POM file. So the format that is being exported is as HTML and XML. This is linked to Jenkins as a post build action. Jenkins is going to read from the XML file to generate the report. So let's have a look at the Jenkins page now. So as you can see here, this is the configuration that we have used for the Jenkins job. So here we are running the Maven command, Maven Cobertura, and the post build action, as you can see here, is to report the XML. So when we run the build, you will the coverage report that has been, so as you can see, this is the build history. We have around 18 builds. So let's look at the previous build 18. As you can see, this is the Cobertura coverage report that has been generated for that. This is the so as you can see, there's the coverage summary and this. Also, the project that we have chosen comes with a set of unit tests that is run at the time of building the project. So let's quickly check the tests that come along with the project. So as you can see, these are uh, the test projects, the test files that are there, that are being executed at the time of installation. So this covers the first phase of the milestone, that is test suites. So as you can see, this is the build 18 console log. So this is the build 18. So let's have a look at the console log to see the execution of the Cobertura task. So as you go down, so we can see that the Cobertura report generation was successful after running the plugin. So if you go back to the project, we can check the coverage report, and here we can see the different packages, and the coverage with respect to the package, files, classes, methods, lines, and conditionals. Perform the advanced testing, we use the fuzzing tool runloop for Java projects. So let's go about. So as we can see, initially, if you look at the test folder that we have, we'll have only 3 test cases that are being generated. So let's run runloop now to generate regression tests, right? So this is the Java command to execute the runloop jar file. So here we can see the inputs being generated and passed to the to each of the classes that is defined. So I'll show you where the classes we have used are used for defining. So before that, so while the runloop is generating the regression test, let's have a quick look at the current state of the coverage. So from the build 18 that we have here, that we showed earlier, we can see that the coverage for each of the tests is methods around 76%, 77% with lines for this particular uh, package. So we can see that each of the classes and the methods have coverage of 67, 82, and so on. So let's see what is the status after. So now we can see that runloop has generated all these regression files. So if we go to the same source folder, let's have a quick look. So now we can see all these regression files are generated by Runloop. So now let's run the Coverture report to get the status of the Coverture. Okay. So Coverture is going to basically build a report by running all the test cases again. So this is the Coverture stage where it's running and compiling the source files that we can see test classes section to generate the report. Okay, so it's now executing the test. Okay, so you can see that the report generation was successful. Let's open up the Coverture report now. Okay, so let's look at this. So as you can see, now we have 100% coverage, line coverage for each of these uh, packages in Java. Let's quickly compare. So earlier, the line coverage for these packages was just 92, 91, and 85% respectively, but now we've got 100% coverage. So this is how we were using Rundoop to generate regression test cases and uh, check. In order for the basic analysis, we're using static analysis tools, namely find bugs and check style, uh, to run on the code. So as you can see here, um, find bugs is basically included as a plugin in the pom.xml file. So find bugs is included in the pom file. This is essentially included in your build section. Now, find bugs. In order to execute the find bugs code, we run maven find bugs. So the find bugs goal has completed, and we can see that 6 warnings were generated after the analysis. In order to view the analysis, we can use the find bugs GUI. Okay, so this button brings up the find bugs GUI, which is really useful and tells you the different kinds of errors. For example, bad practice, format string problem is one of the errors that we're facing. It also tells you exactly in which part of the code this is seen and what the correct format is, and also highlights the error. Similarly, another one that we can probably look into is internationalization and how to correct this error. So Findbox is useful. Another interesting another aspect is that it's integrated with Jenkins, so you can see the Findbox trend that is being seen in Jenkins dashboard, and the warnings that you see here are exactly the same as what we saw from the Findbugs GUI, the bad practice section. So that is Findbugs. The next tool that we used was for static analysis is namely checkstyle. In order to run the checkstyle goal, we run the below command, name checkstyle. This is running. We can see that the checkstyle is included in the pom.xml as in the build and the reporting sections as below. So this is the checkstyle plugin that is included, and it's also included in the reporting section. So now we can see the checkstyle is completed and it's detected 199 checkstyle errors. As before, this is included in Jenkins as a post-build action, and we can see the checkstyle warnings that we saw. So this is the latest build, and we can see the exact same number of errors that we saw, and in which package the errors are, and it all tells you which method and details as such. So it tells you exactly what are the errors and where it's being detected.
For the fourth part, we implement our own custom metrics. We use the checkstyle library to help us with that. We create a new Eclipse project, and then we create a project where we make our own custom metrics. So these are all the custom metrics that we create in separate Java class files. So basically, for the first metrics requirement, we have a class which calculates the number of conditions in an if statement. Then for the second, we have created metrics that calculates the number of lines inside a method, and that gives us that can tell us whether a method, how much long a method is. So currently we have given the max limit as 30. For the freestyle requirement, we did two different custom metrics. One is the method limit check, which checks the number of methods inside any other method. Our maximum limit is 5, and then we also find the cyclomatic complexities of each method. After we build our custom metrics, and then we import the Java jar file into our own project where we want to analyze it, and then we run the Maven goal, which will use the jar file and then create the checkstyle report for us. So for running the checkstyle Maven goal, we have to create our own custom checks XML file where we list all the modules we want to run. So these are basically the modules that we have created, and now the Maven goal is running the checkstyle modules that we have specified here. So the build is successful, and the checkstyle report is being created. So now let us go and see what the checkstyle report looks like. Okay, so we have a HTML file which will detail all our checkstyle results. So as you can see, we have a 19 info and 6 warnings. So basically the warning is for here it is for cyclomatic metrics. A method has 8, whereas we allowed only 4. Then there was a method whose length exceeded our maximum length of 30, and these are the info for the maximum conditions inside if statement. As you can see, 1 2 2 1, and then finally there was one more custom metric, which is the method limit, and as you can see, we have allowed only 5 method inside any other method, but here it must have crossed that maximum limit. So this is these are all the custom.
Implement the bonus question, what we did is we used the strict duplicate code module that is available for checkstyle, So this is the code that we use. Now if you were to run the Maven check style so this is the only one that we're using, and also this is referring to the custom checks XML file. So if we're running the Maven task now with check style, we have set the value as only 2. So any recursion having 2 elements will be detected. As you can see, we have 854 check style errors in this case. Now, so this is how we did the bonus question. Thank you. Okay, in order to perform the gates, so what we've used is post commit hooks. So as you can see here, um, so this is the post commit hook that we're using. Essentially, what the hook does is it checks with the Jenkins API, the web API for the particular job that we have configured. It keeps curl to get the status of the job every 20 seconds. So if the status of the job is complete and if it's a failure, then what the hook does is it resets it to the previous commit. So the new commit that is sent will not be accepted. So let's check out this feature. So this is the readme file that I have. So I'm just gonna edit it here, right? So now I do a git add readme git commit -m. I just make sure that the chmod is correctly set for dot get hooks post commit. So now I run the post commit hook. No, so now I do the git commit. So as you can see, as soon as I did the commit, it's triggered a build. So if we go to the Jenkins UI, we can see that build 25 has started. So let's monitor the status of build 25. As you can see, while the build is running, the the hook commit, the script that is running is constantly polling every 20 seconds to get the status of the job. So the script is so job is almost reaching completion. So here, yeah. Okay, so we can see the job has completed. Now if you look at the recent job console output, we can see that the build failed. So the build failed due to the null point exception in a particular test. So let's look at what happened to the commit. So as you can see, um, we see the logs that the commit resulted in a failure reverting to the previous commit. Now if we check the git log messages, we can see that the the recent commit that we did. So I'll just show you the commit that we did. The recent commit that we did was edit readme, but it's not in the git logs. It says that the commit did not take effect. So this is how we can use post commit hooks to filter commits if there is a build failure. To implement the second part of gates, basically what we have to do is if the commit basically using check styles to check for any method and custom methods, and if the method is incorrect, the commit will be rejected. So in let's look at the pom.xml file that we're using. So this is this is the custom configuration that we have put in. Basically the config location is in custom checks.xml and fail on error is true. So if you look at the custom config file, we can see this is the custom config file that we're using. The main module that we have to look at is the cyclomatic complexity, where we are checking for a value of 4, and if it exceeds, it will result in errors. So this is what is going to trigger errors in this case, because we're using the custom file. So yeah, so let's look. So we're going to edit the readme file now. Just a simple edit here. So now I'm going to git add readme, git comment, right? So this is going to create a job, and it's going to run a Jenkins job, and we have to see if it's it's triggering the build now on Jenkins. Let's look at Jenkins. So as you can see, we can see job 27 has been triggered. But what we have to keep in mind is we have a custom check that is applied that is checking for errors in check style, and if the so we have fail on error set to true. So let's look at that. So we can see that build 27 failed. So if we go to the console output, uh, we can see that when we ran the Maven rule, there was a build failure because of the check style errors that were seen. So as you can see, the check style it failed due to check style errors, the build. So the easy way to get around this is basically just to change the and also we can see the build action just didn't accept the commit and it reverted to the previous commit. So the build action would be now go to pom.xml, custom check. So what we'll do is we'll comment this out, right? So this section is being commented out so that we don't fail on error and the build goes through. Basically you just chill not to check the custom condition. So this is done. So now I'm doing git add pom.xml, git commit -m. Okay, so we can see that the build has been triggered in this case. So let's look at the Jenkins CLI. Okay, so we have job 28 that is being running now. That is running now. Let's look at the output of this job. So basically now we are saying that, so as we can see, build job 28 has run to completion, and the build is successful in this case. So essentially this way we can have check style check for errors and fail if there are errors seen or not by changing this parameter.